Here's an example of a game of chance using combinations. So if there are 6 cards, 3 of which have walleyes on them, one crappie, one sunfish, one bullhead, a player will draw 3 cards, and if that player selects all 3 walleyes, they win $25. If they select 2 walleyes and one other, they win $10. If drawing one or less walleyes, the player chooses $1. Calculate the expected value of the game. So again, I'm going to have my events.
You bet, take care.
My gain-loss, my probability. My events are the 3 walleyes. That's going to win $25. 2 walleyes, $10. And other, so 1 or less, they're going to lose $1. Okay, now calculating this probability. This is combinations. So what I'm doing is I am choosing 3 from 6, where order doesn't matter, and to get all 3 walleyes, there's 3 walleyes, and I'm choosing all 3 of those. This combination 3 choose 3 is 1, and combination 6 choose 3 is 20. So this is a 1 in 20 chance. Now you might look at this and say this is not going to work out very well, because if it's a 1 in 20 chance and you're giving out $25, you're giving out too much money there. But we'll fix that later. The 2 walleyes. So now again, to calculate this probability, it's 6 choose 3. There's 3 walleyes. I need to choose 2 of those. There's 3 other cards. I need to choose 1 of those. And that will be multiplied because it's AND. So 3 combination 2 is 3, and 3 choose 1 is 3. So it's 3 times 3 on the top, which is 9, over the 20, which is that probability. Now all the other ones, which would be either 1 or 0 walleyes, and you could calculate both of them and add them up, but it's always easier at this point to just find the probability of winning something, which is 10 out of 20. So therefore the probability of losing something must be 10 out of 20. Calculating this expected value, I would have 25 out of 20 plus 90 out of 20 minus 10 out of 20. Adding these together, 25 and 90 is 115, minus 10 is 105. So I have 105 divided by 20, which comes out to be 5.25. So this expected value, that's a positive 525. That means that this game is in favor of the player, and a definite favor. So every time you play this game, every time you draw 6 cards, you'd expect to win about $5.25. This would be a game that would be a great investment. If you know it has a positive expected value, you should play the game as many times as possible, because in the long run you are going to win. And in this case, you're going to win about 5 times the amount of money invested. All right, so now we're going to alter this game. So we just had our events, our gain-loss, our probability of each one. And we did have the 3 walleyes. We're at $25. That's a 1 in 20 chance of happening. The 2 walleyes was at $10. That was a 9 in 20 chance of happening. And then we had our others, which lose $1, and that was a 10 out of 20 chance of happening. Okay, the expected value was $5.40. They were winning way, way too much. All right, so I'm going to alter this a little bit. I have to decrease the prizes in this example. So I can decrease the 3 walleye prize and the 2 walleye prize. 3 walleyes is a 1 in 20 chance of happening. I'm going to go with $5 for this one. Because thinking ahead, I'm going to be multiplying these together. So that's going to be 5 out of 20. The 2 walleyes, this is going to happen 9 out of 20 times. This is going to happen almost half the time. So I can't go real crazy with the prize here. I'm thinking either $1 or maybe just making this a break even. So let's start with $1. Okay, if I calculate this, I start multiplying my gain loss times my probability. I've got 5 out of 20 plus 9 out of 20 minus 10 out of 20. Adding these up, 14 minus 10 is 4 out of 20, which is 1/5. That's 0.2 positive. So in this case, they're winning 20 cents every time they play the game. Still need to make some changes. So I can think my grand prize might be too high. Couple different ways you could do this. I'm going to decrease the 3 walleyes. I'm going to make this a $3 winner. Keep this at 1. If you see that, that's going to make this 3 out of 20. I'd still have 9 out of 20. That's still only going to be 220. It's still going to be positive. So pretty obvious here that I've got to make this change. The 2 walleyes, half the time, I'm just going to get my money back when I do that. I'm going to make that 0. Paying $1, getting $1 back. The 3 walleyes then, I can be a little bit more aggressive here. Let's make this $8. So now changing these, I'm going to have 8/20ths, 0/20ths minus 10/20ths, which will come out to be a negative 2/20ths, which is a negative 1/10, or a negative 0.1. Okay, so in this case, they're not losing enough money. They're winning too much. So keep working. The only really thing I can do is just change this grand prize winner. And let's change this to 6. That's going to change this to 6/20ths. I'm going to end up with a negative 4/20ths, which is exactly a negative 0.20, which is what I want. So that's an example using combination.